presentation of physics for class 10th, and your topic is that is refraction by lenses. So these are the contents by spherical lenses. Refraction of light, it is the phenomena of change in the direction of the path of light when it goes from one medium to another medium. So your topic is that is spherical lenses. A lens is a piece of transparent material bounded by two refracting surfaces out of which at least one is curved. So we have two types of lenses, convex lens and concave lens. Convex lens, if central portion of the lens is thicker than its edges, then it behaves as a convergent lens known as convex lens. Convex lens is a lens which is thicker at the middle and thinner at the edges. And the concave lens, if the central portion of a lens is thinner than its edges, it behaves as a divergent lens known as concave lens. Concave lens is a lens which is thinner at the middle and thicker at the edges. And the uses of lenses are commonly used to correct vision defects of human eye. It is used in microscopes, telescopes, cameras and projectors. So these are the terms used in lenses. Optical focus, the center point of a lens is known as optical focus. Optical center, the point in the lens through which rays of light passes undeviated, that is optical center, which is denoted by the letter capital C. Principal focus, the point on the principal axis where the incident rays of light parallel to the principal axis or appear to meet after refracting through a lens, is called principal focus, which is denoted by the letter capital F. And the focal length, it is the distance between the optical center and the principal focus, is known as the focal length, which is denoted by the letter small f. Focal length of a convex lens is positive, while that of a concave lens it is negative. So these are the rules for drawing ray diagrams. A ray of light parallel to the principal axis passes through the focus after refraction. A ray of light passing through the focus becomes parallel to the principal axis after refraction. A ray of light passing through the optical center goes straight without changing its path. These are the diagrams. So your topic is image formed by convex lens. We have a 6 image formation by convex lens. This is the table image formed by convex lens. Position of the image between small f and lens capital F. Position of the image on the same side as object. Size of the image enlarged. Nature of image virtual and erect. Position of the object at focus f dash. Position of the image at infinity. Size of the image highly enlarged. Nature of image real and inverted. Between f dash and 2f dash, position of the object. Position of the image beyond 2f. Size of the image enlarged. Nature of the image real and inverted. Position of the object at 2f dash. Image is 2 at 2f, and the size of the image same size as object. Nature of image real and inverted. Position of the object beyond 2f dash. Position of the image between f and 2f. Size of the image diminished. Nature of image real and inverted. Position of object at infinity. Position of image at f. Size of the image highly diminished, and the nature of the image real and inverted. So the next is the image formed by concave lens. When the object is at infinity, position of the image at f1, size of the image highly diminished, point light, nature of the image virtual and erect. Position of the image between infinity and optical center. Position of the image between focus f1 and the optical center O. Size of the image diminished, and the nature of the image virtual and erect. These are the images formed by concave lenses. So these are the sign conventions for lens. The sign conventions for lens are same as those for spherical mirrors, except all the distances are measured from the optical center, while as the distance are measured from the mirrors, that is a pole. Distance to the right of origin is positive along x-axis, while that of its left, that is negative along x-axis. Distance above the principal axis is positive along y-axis, while those below it is negative while along y-axis. And your next topic is that is length. Length is the relation among the distance of object, that is u is the object distance, and the image, that is v, from the lenses. And the focal length, that is f, small f, of the lens is known as lens formula. Lens formula is the 1 by v minus 1 by u is equal to 1 by f. The next is the linear magnification. Linear magnification by a lens is defined as the ratio of the size of the image to the size of the object. H dash is the size of image formed by a lens. H is the size of the object. So the linear magnification is m is equal to h dash by h. M is equal to h dash by h is equal to v by u. V is the image distance, u is the object distance. And the next slide is that is power of a lens. Power of a lens is the ability of a lens to converge or diverge the rays of light falling on it is known as power of a lens. Power of a lens is equal to the reciprocal of the focal length expressed in terms. P is equal to 1 by f in meter. P is equal to 100 by f in centimeter. So the SI unit of the power of a lens is diopter, which is denoted by the letter D. Power of a lens is 1 diopter if its focal length is 1 meter. Power of convex or converging lens is positive and power of concave lens is negative. Thanks, my dear student.